So a proof is a logical argument that shows a statement is true. Now, logical. So we've learned a little bit about logic. So you can't just use stuff that we haven't proven that isn't a fact, so that they can all be very deductive in reasoning, so that you can't argue against it. There are several different forms. We are going to show you a two-column proof. I'll be kind of honest. Usually, the higher up you go, you use them less. But what's nice about a two-column proof is it's very organized. And you definitely have a reason for every statement. And eventually, you learn to speak like a two-column proof. You will say, well, these two things are congruent because I've given that information. These other two things are congruent by substitution, right? So you start speaking in proof language once you get really used to it. So that's why we're kind of concentrating on two-column proof first, where you have your statements and your reason, right? So each statement is either something that you're given or something that you've gotten here by applying some other property, some other fact to it. And you have to say which fact that you're using to get from one place to the next. And we see. You make one statement at a time until you get to your conclusion. And because you're making statements based on facts, what kind of reasoning are we using? Deductive reasoning. We're using very deductive reasoning. Because why are we using deductive instead of inductive? Yeah. Yeah, with inductive. Inductive is, I'm noticing some patterns. I think it's going to continue this way. We want very, strong proofs, deductive reasoning, where you can't argue and say, well, I found a counterexample, because there won't be any, because everything's based on fact. Usually, but not always, but usually, you start with at least one piece of given information. Okay. So here is a proof, and I don't think I've got this on your notes here. There's a lot that's not on your notes, so I'm thinking you might want a piece of paper to kind of catch some of the stuff that isn't on your notes, so you can kind of work along with it here. Which one? Oh, so we're good. Okay. Now, why? Why? So you saw that these two things are equal, right? So by some property, I can say this one equals that. Which property? Transitive? Yes. Or if you said substitution, I'm not going to say you're wrong. Fantastic. That brain's starting to go there. We're starting to look. We're starting to solve the little puzzle. Yes, sir.
So, is transitive basically kind of like substitution?
It is. I like to think of it as a form of substitution property. So I tell sense, I don't know if they're necessarily always exactly interchangeable, but I can kind of see where you're going. Okay, so do I get here? Am I getting AB equals B equals AC? Am I getting there? Yeah.
Yeah, by subtraction.
Subtraction property, so how do I subtract it? Subtract AB?
Yeah.
Oh, this should be a boost. So what's going on here? That should be a boost. If I subtracted AB, right? Did I get that? So subtraction property of equality. So that's kind of cool. So we kind of look at what we got, and you're starting to even be able to fill in the actual reasons, statements, which is good too. To proof, writing a proof. You have your given, you have what you want to prove. If they don't give you a diagram, you draw the diagram. Sketch first, make sure you have a reason for everything, and make sure your reason isn't as a miracle occurred. Remember that was in our other chart. It has to be something we've proven already or we know to be true. Nice. Okay. Theorem. So the things that we can include in proofs, we can include lots of things. We can include definitions, properties, postulates, and theorems. We've discussed theorems a little bit. These are conjectures that we have proven. So you kind of do some inductive reasoning, you throw out a conjecture, and now you've proven it using one of these deductive type proofs. Now this theorem is another fact that we can use. Once we have proven a theorem, I can use it elsewhere. So let's see what I got here. Segment angle congruence. It's reflexive, it's symmetric, and it's transitive. What am I talking about here? I'm talking about reflexive. Now remember what they are for equality. Yeah, but remember, and I kept stressing, when you say reflexive, you have to say reflexive property of equality. When you say addition property, I always make sure you have the equality, because now what am I working on here? I'm working on congruence. I'm missing a little congruence over there. So reflexive is different for congruence than it is for equality by design. Reflexive for equality that's A equals A. And what is it for congruence? A segment is congruent to another segment. What's the difference between equals and congruence? What's the difference? Equals measure. Yeah?
Congruent is equal is the exact same thing. Congruent is the exact same size.
Yes. So if two things are equal, they are the same thing. So measures equal, we can have same measures, the same number for both. But when you say things are congruent, I always think that word clone. They have the same size, the same measures, but they're two different objects. So I have two different segments, or I could. I guess I don't really do. But you can. So AB is congruent to AB. Obvious, maybe. Symmetric property, when we looked at symmetric for equality, that was if A equals B, then B equals A, right? So equals. But now we're working with congruence. So two congruent segments. If AB is congruent to CD, you can turn it around. CD congruent to AB. Transitive. So again, remember for equality. That was if A equals B and B equals C, then A equals C. So it's the same idea, but with congruence now. AB congruent to CD, that same segment CD congruent to another segment, EF, then you can conclude that initial segment, AB, is congruent to EF, transitive property of congruence. What do you think is going to be for the angles then? And I'm over here now if you're keeping track on your notes. Okay, so what do we think it's going to be for angles? For any angle A, what do you think the statement's going to be? Reflexive. What do you think? Angle A is congruent to angle A. Because now I'm working with congruence. Working with congruence. What about for symmetric? If I know angle A is congruent to angle B, then what does the symmetric theorem of congruence say? Yep. Angle B congruent to angle A. Same thing, I can turn them around. I know it's true for equality, now I'm stating it's going to be true for congruence. Transitive property for angles. Angle A is congruent to angle B congruent to angle C, then, yeah? just say, these are true because they're obvious. Now, we kind of went there for equality. We said they're obvious. But don't we want to limit the number of postulates, number of assumptions? Why do we want to limit the number of postulates and assumptions that we use when we prove stuff? Why?
Because if one of them is proven wrong, then everything based on the postulate.
Absolutely. So if we make too many assumptions, then what happens if it turns out this isn't true, and I base something else on that, it's not true either, and this could be a mess. So things that we can't prove, we do prove. So we're going to prove something. So let's look at segments. And I'm over here, you can follow along on this paper here, hopefully. Reflexive theorem of segment congruence. So if AB is a line segment, prove AB equals, congruence symbol not showing up. We are proving congruence. So AB is a line segment. Now that's on your paper too. Make that a congruence on here. AB congruent to AB. So AB is a line segment. Why can I say AB is a line segment? How come? Given to us. So AB, now what's the difference between the AB with a line and the AB with no line? Yeah, what's the difference? The measure. So how come I can say, since AB is a line segment, AB equals AB, the measure? How come I can say that?
The measure is on numbers, not the actual line.
That's right. So, what property can I use? What can I use?
Reflexive property of
The reflexive property of equality, right? This is one we're working with. We're saying that's a given property that we know. So I can say AB equals AB. Their measures are going to be equal because I have a reflexive property of equality for numbers. So now where can I go? How can I go right now to saying, well, then they're congruent? Oh, these little congruent markers did not come out. So fix it on your paper as well. They should be congruent. Why? 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 Yeah, I mean, I can read it too, but what is the definition of congruent angles or segments? Why can I say that? Why? What is that? What is that? Yes. If two segments have the same measure, then they are congruent, and also if two segments are congruent, they have the same measure. That is a definition of congruence. So we can use that. So here I am. So now, because I have proven the reflexive property for congruence, I can use it in other proofs. Let's do the same thing again, but we're going to work with the angles now. I'm given an angle A, and I want to prove that angle A is congruent to angle A. So angle A is an angle, same like the other one's given. So how come I can say the measure of angle A equals the measure of angle A? Yeah? It's reflexive. Same thing equals. Reflexive property of equality. Because now I'm looking at equality. So how come now I can make the statement that they are congruent? Angle A congruent to angle A. Because, yeah? Because the measures are the same, and that's the definition of congruent angles. If the measures are the same, they are congruent by the definition of congruent angle. So now we have two new theorems. These are theorems. So now I can say, if I need to, in another proof, angle A congruent to angle A, I can say that because of the reflexive property or reflexive theorem of congruence. Let's look at some of these other ones. Symmetric. Okay, so I am stating, I gave you this conjecture that if you know that AB is congruent to CD, then CD is also going to be congruent to AB. So my given, AB congruent to CD, that's given. AB equals CD because why? Yeah. Yeah, the definition of congruent segments. If two things are congruent, they're going to have the same measure. I know where we are because this is a great little thing because these are kind of simple ones, but there's a lot of important concepts in here. So now what can I say, knowing that AB equals CD, what can I do now? Yeah. How come? Of equality, right? The symmetric property of equality, we have that. So we can use that in a proof. I can turn equals around. Now once I know that two measures are equal, what can I say about these two segments? They are congruent. Why? Yeah? Definition of congruent segments. Exactly. So we're changing this into something we know how to do, and then we're kind of changing it back. So let's look at it for angles. I'm given that angle A is congruent to angle B. How can I prove that angle B is congruent to A? So let's start with our given. Angle A is congruent to angle B. What do you think the next statement should be? Well, I'll tell you, it's on the paper, right? Their measures are equal. How come? Yeah? Definition of congruent angles. So now what can I say? Yeah. Now I can turn them around now. Because why? Why? Symmetric property of equality. Once I have this now, what's my next logical step? Where am I heading in this guy? Yeah? Yes. Once I know their measures are equal, I can state they're congruent by what reason? Once again, the definition of congruence in this case for angles. So we're using the stuff we know, and now we have new stuff we can use. We might need to use this in a proof, and now I can. I don't have to reprove it. So if I have a situation where I need to go from here to here, I don't have to state in the proofs again, the measures are equal, therefore the other things are equal. I can just go straight there. Okay? Let's do the last one. I think it's the last one. Transitivity. So let's look at the segments. AB is congruent to CD, CD congruent to EF. I want to prove that those two things are congruent. So I'm going to start with my givens. What do you think we should do next? I've got congruence. Yeah, what do I do? Because? Right. So I'm saying because they're congruent, their measures are equal. Well, once I have equality, what can I do with that? Yeah? Transitive property, therefore AB has to be equal to EF, their measures, by the transitive property of equality. Once I have this statement, I go back to saying, well, now I can go to congruence again. AB congruent to EF, definition of congruent segments. Who's this making sense for? I got about 4 or 5 people. If it's not making sense, you need to ask the question. Go, what? I want to ask a question. Okay, angles. Same idea. I'm just working with angles. So here's my given. Angle A congruent to angle B, angle B congruent to angle C. That's my given. I don't know yet anything about congruence, but I know things about equality. So let me go ahead and figure out what goes next. What goes next? I can't do anything in here. What do you think? The measure of angle A, right? Because I know they're congruent. So I want to say something about their measures now. The measure of angle A equals the measure of angle B. And Maria, why can I say that? By the definition of congruent angles. Absolutely. What now? What has to happen now? Yeah? What am I going to do now? The measure of angle A. Well, why do I keep making a big deal about saying the measure of angle A equals the measure of angle C? I'm making a big deal. Why is that? I don't know, because you make a big deal about a lot of things. Why do you think I do that?
The measure of the angle is a number, and the angle itself is like a number.
Right.
So if you're saying postal A is getting a number B, that's not true, but can the measure of angle A is measure of angle B?
She's absolutely right. When you say angle A equals angle C, I know exactly what you mean. I know what you mean. I know. But we're being really, really picky. Because the angles themselves aren't equal, they're two different angles. But their measures are the same. Their measures are equal. So it's just being picky, but it's being picky in a very, very mathematical way. And those of you that make it to the tippy top of the mathematics chain, and I know some of you are, you're going to talk like this. And people get annoyed with you because you're going to correct them all the time and stuff. But that's okay. And that is, again, transitivity of equality. We know about that. So now I can conclude that angle A congruent to angle C by, again, the definition of the congruent angle. So this it's a subtle difference. Congruence versus measures being equal. Once you really get that, I think this makes a lot more sense. All right, what do you guys think? Up, middle, down. Where are we? If you're a middle or a down, you need a question. Where am I losing you? Now they're like, no, we're up. We're fine. And now we're fine. Yes, ma'am.
There was one
What this means, congruent segments, the definition is if you have segments that are congruent, they have the same measure. And if you have segments that have the same measure, they are congruent, because that's what congruence means. They're two different line segments, but their measures, their lengths are exactly the same. So that's what I mean by definition. You could just say, you know what, it's okay. You just said definition of congruence. I'm okay with that. We're being like splitting hairs a little bit, but congruence says if you have the same measure, then, measures are equal. Yeah? Okay. Name the theorem. Now that we've proven our new theorems, we can use them. Okay, so we want to draw some conclusions. So if I have, we're on page 2 here, and I don't think this is on there. So we're just going to look up here. It's not in the notes. If angle R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. Well, who says I can say that? Yes? Transitive something, it's like he's not sure what the word should be. He knows it's not equality, so what can we say? I do the same thing you do. I tend to say property because I'm used to it, but this is actually a theorem now. It's the transitive theorem of angle congruence. It's a lot of words. But now I'm not saying property so much anymore because it's a theorem. We've proven it. It's a theorem. How about if NK, segment NK congruent to BD, then segment BD is congruent to NK. Isha, who says I can say that? Congruence, right? So symmetric theorem of segment congruence. These are like, the very longest thing you could possibly think of saying. Segment CD is congruent to segment CD. What's that one? Reflexive theorem of congruence. Angle Q is congruent to angle V, then it must be that angle V is congruent to angle Q. So what can I say? Symmetric theorem of angle congruence. So the words, it's a mouthful, but these were proven. They are theorems now. They're not properties that were just telling you are true. We proved them. Excellent. All right, so now 4 more proofs. So let's see if we can do these. What am I given? Now see, I've got this diagram. They gave me part of it. They didn't do the given. When you see a diagram, you've got to mark it up first. So AD equals 8. So you're going to go to your little picture here. AD, where's that? That's this one, right? 8. BC, 8. And now they're telling me that BC is congruent to CD. All right, where's BC? BC, that's this one. Is congruent to CD. So I'm marking up my diagram. Marking it up. So if I marked up my given, now where am I headed? I want AD to be congruent to CD. Now before we even begin, can we see how we're going to get there? Yeah. Now we can kind of see, we'll just use a different color, say this one isn't given, but these have the same measure. 2 sides have the same measure. What can I say about them? The segments are congruent. So I know that. So it's kind of like you have to figure out the problem first. Then you have to figure out, well, how am I formally going to say it? So for now, I'm going to start giving you some of the statements, but we're going to have to start learning how do I fill in. So what is this? AB equals A, BC equals AY, given. Now I'm saying AB equals BC, which is exactly what Rachel said. What is the formal reason I can put here for that? How come I can say that? How come? Yeah? How come I can say that? Substitution property of equality or transitive property of equality. This one is 2 transitivity, but that's fine. Substitution is a plain statement here. Okay, so we're getting at exactly what Rachel described, right? You can see where we're going. Now I'm saying AD segment. These 2 segments are congruent. AD and BC congruent. How come? How come? How come, Rachel? Yeah, the definition of congruent segment. Because that's it. The same measure, they must be congruent. So So now what? I'm saying BC congruent to CD. How come I can say that? How can I say that, Madeline? It's given. It's right up here. So the givens don't all have to be up front. You could, but you don't have to. And now I'm going for the conclusion. AB is congruent to CD. How'd I get there? How'd I get there? Yes. The transitive theorem of congruence, a segment congruent. So, because this is congruent to that, same thing congruent to this, these two things are going to be congruent by the transitive theorem of segment congruence. Wow! Now I see where this is going, Michael, said everybody in this room. Let's try another, Rick, try another one? No. Yes! Okay, so let's see, I got my diagram here. First thing, I got to mark my diagram. I'll wait. So AD equals 12. So let's go to our diagram. AD equals 12. AB equals 12. That's this guy. BC congruent to CD. That's BC. He's congruent to CD. What else do I know? AD congruent to CD. So I can say, well, CD is also going to be congruent to AB. So I'm getting kind of this, right? Do I have the kind of the right picture here? Yeah? Is it the same thing as last time? Let's see. What are we trying to prove? We're trying to prove BC. We're trying to prove this guy is congruent to AD. And you're saying it's kind of the same thing. It is. I think it might be, so it should be easy, right? Let's see. All right, so we're starting with a given with these sides of 12. That's given. So how come I can say AD equals AD? Yeah. Transitive property of equality, substitution is okay. Now I'm saying the segments are congruent because, right? Definition of the congruent segments. Where should I go next? What do you think? Not ready to guess yet? I'm going to say that BC congruent to CD and AD congruent to CD. Why can I say that? The given, they told us. So now I'm concluding that BC congruent to AD. BC congruent to AD. Where's that coming from? Awesome. Better you're saying it than me. The transitive theorem of segment congruence. Now I'm going to go to my conclusion. Well, how am I getting to my conclusion? Where's that coming from? Yes? Well, where you come from? I don't know if I have substitution property of congruence, do I? Is there a transitive going on? I've got this. Okay, I know this. BC. Oh, I wish I knew something about AD. Oh, wait a minute. Will that give me some transitivity? Right? If AD, BC, I think that will be okay, right? So I'm getting a transitive theorem of congruence there. Oh, yes. The theorem is something, we just proved it. They're not giving it to us, it's not an assumption. The other one, a property, it's like a given, it's more of an assumption. This we proved. Let's try a different one. Alrighty. Oh wow, I'm so sorry. Let's see. Angle ABC congruent to angle CD. So where's ABC? ABC. ABC. This guy is congruent to CBD. This guy. And using the one arc on each of them says they're congruent angle. CBD is 50, so they already marked that for me. And CBE, this one. So it's this whole big thing is 100. That whole big thing. What am I trying to prove? ABC is congruent to DBE. Oh. So I'm trying to prove, let me see if I can mark that here. ABC, I want to prove that one's congruent to this one. DBE. Right? If I'm reading it right, hopefully I'm reading I'm going to add up to that big angle by the angle addition postulate. It measures up two of the smaller ones, right? You're going to add it to the bigger ones. 50 degrees was angle DBE equals 100 degrees. Now, where's that coming from? Okay, I heard it. I said it. How did I get from CBD to be 50? Well, that stayed the same, and CBE went to 100. How did I get that? How did I get that? What we use? We can use substitution because I'm substituting in the fact that it says right here, CBD equals 50. So here CBD substitution says that means wherever you see that, you can put in a 50. Same thing with CBD. Wherever I see that 100, CBD, I can put in a 100. So that's pure substitution. Angle DBE equals 50. The measure of that angle is 50. Whoa, how did I get there? How did I get there? What? Is this given? I'm looking up. It's not given, but I got it from this one. What did I do the previous statement? I did. I subtracted 50 from both sides. So which property is that? Subtraction property. Right. Okay. Angle CBD equals something. Well, what's angle CBD going to be? Let me see. That's this one, right? What is the measure of angle CBD? Yes. What is it? 50. Because? Taking DBE, sorry. Yeah, sometimes we're only going to look. If we know it's 50 from up here, our given. So now I'm saying this one is the same as the measure of DBE. These are getting harder. Okay. Blank and blank. Oh, let me help you out here. So now I'm saying angle CBD is congruent to DBE. Because why? How do I get from here to here? Yeah. Definition of congruent angles. And now I'm saying we have our conclusion. Angle ABC congruent to angle DBE. Where's that coming from? This, right? Yeah? Well, congruence, right? So we can look at the sign to know if it's equality or congruence. So the ABC is congruent to CBD, and CBD is congruent to DBE, and ABC is congruent to DBE. Yes, sir?
On the second step, did you say
Did I say that? Do I have a reason for it? You know, possibly. And I'm not saying these are the only ways to do this proof, but you have to be able to break down step by step. It's very possible there's a way to go down that path and get it to work. Very possible. There's more than one way. I actually find it almost harder doing somebody else's proof because, you know, you can think about them a little bit differently. There's more than one way. Okay, let's try this guy. Where am I now? I think I'm on that fourth one on the page 2. Oh, goodness. What do we have with this one? AB congruent to BC. So again, first thing, mark up that diagram. AB congruent BC. BC congruent to CD. Oh, that's going to be like that. And then CD, that's going to be AD. So we're seeing something going here. Now it says prove the perimeter of AB and CD is 4 times the length of AB. So let's think it through. Before you start solving, you're like, wait, okay, can I convince myself of it first before I kind of formalize it? So can we kind of say they're all going to be congruent, right? How do you find the perimeter of a 4-sided figure like this? Perimeter? How do you find perimeter? No, perimeter. Perimeter's like the fence. What's perimeter? You add up all the sides. Now, if this side is x, right? Aren't all these going to be x? Whatever it is. So don't I just do 4 times that? Won't that work? Because they're all the same length. So the first thing you really do with any of these is you just kind of have to convince yourself, okay, I see it. Now, how do I kind of formally state all that? So we'll start with our givens, all our congruent sides here. So now I'm going here. I'm going to their measure. I'm going to the level of their measure. And why can I say that? Yeah? Well, it's transitive. Did I say because something equals something? And what? Let's look at from here to here. Because these are congruent, I'm saying their measures are equal. Because these are congruent, their measures are equal. Because these are congruent, their measures are equal. So which one is that? Which one is that? That's the definition of congruent segments. That's going from a congruence to an equal or an equal to a congruent. All right, where are we going from here now? I'm saying AB equals CD, and then AB equals AD. Yeah. Okay, what are we substituting? Yeah. So transitive or substitution property of equality works fine here. So I know we've got some AB equals 2 different things here. So now perimeter of ABC equals AB plus BC plus CD plus AD. They're measures. Well, how come? Because that's what a perimeter is. Perimeter is adding up the sides. That's a definition. Right? It's a word. We don't know what the word means. Let's tell you what it means. It means add up all the sides. So then, what do you think? Where am I going with this? What do you think? I am saying this. I'm saying AB. Now my BC, instead of writing BC, I'm writing AB. Instead of writing CD, I'm writing AB. Why am I doing all that? Why am I doing that? Right. So what property says you can just replace them? This substitution, right? This was a little bit more purely substitution. They're the same thing. I'm just going to put it in there. Okay, well, look at this now. We're there, aren't we? What's AB plus AB plus AB? Those are 4 ABs. And then I'm just adding. That's like simplification. Adding. Just adding. Simplifying an expression. How we get there. So it seems like, this is a lot of work to prove what might be semi-obvious. But the goal for this is not like, gee, how hard can we make a simple idea? It's to learn how to get your thoughts step by step by step, the reasons for every thought. So if we started with really hard ones, I think that would be ridiculous. So we're just kind of learning the method, How many more can there be? A lot. Wow, there's a lot of these. Okay, now this one, I'm saying explain your steps. There are other kinds of proofs. Besides 2-column, we have what are called paragraph proofs. Paragraph proofs are just, it's written in a paragraph, English paragraph, but you have to justify every single thing you say. So let's just look at this. We've got angle D is congruent to DEG. So here's angle D, and it's congruent to DEG. So let's find DEG. So again, mark your diagram. Always, always, always. Now what else do I know? This line EG, or segment EG, it's bisecting DEF. DEF. So it bisects this whole angle. What do angle bisectors do? What do they do? Yeah, it divides the angle into 2 congruent pieces. So what do I know about these 2 angles? They're congruent also. So now if I want to find x, what can I do? Now I can see that these 2 angles are congruent, right? And once those 2 angles are congruent, I can solve this. Now I have to explain it. I can't just, okay, I did all this in my head. So you know all those years of show your work, show your work, show your work? Remember that, all those years? It's come to fruition. It's now the reason why we're always like that. Because I don't know what's in your head, nobody knows what's in your head. You have to tell, and now we're learning how to more formally tell. So let's think about ways to discuss this. One way, let's see, since we are given that EG bisects angle DEF, we know that angle DEG is congruent to angle EFG, or GEF. Since bisectors create two congruent angles. Okay, so I'm explaining every single thing like so carefully. Okay, what else do we know now? We also know, we also are given angle D is congruent to angle DEG. So by the transitive theorem, of angle congruence, we know what? Angle D is congruent to angle GEF. Right? Let me just write this stuff out. Therefore, their measures are equal. These three dots mean therefore. Therefore, the measure of angle D equals the measure of angle GEF. So, 4x equals 2x plus 30, which means 2x equals 30 by the subtraction property of equality. And x equals 15 by the division property of equality. This is way too much. Wow. We like the other way better. But if you ever try to read somebody's like, in a math book, you ever try to read a math book way up there, this is what you read. Or maybe somebody's trying to prove something, prove, their thesis even, who knows. Wow. Now, are there shorter ways? As you get used to doing this, there are more concise. But you have to kind of get it. You have to be able to answer every why. Why? Why can you say that? Well, because of that. Well, why? What do you think? They're not happy. I think I have shorter words than you, I can't remember yet. So if you look at this online, I have very similar words. I just kind of did these off the top of my head, but very similar words. So paragraph proofs, after a while, you start to like them better than two columns. At least I did. But two columns are really good to start with. But just, there's other ways of writing proofs. And then, so we're going to have some, that's not it. Now I'm wondering, I think what I'm going to do, should I stop here? Huh? Sure.